All right, let's talk about the invisible safety net that stops your entire digital world from grinding to a halt. It's called DHCP Failover, and honestly, it's one of the most important and totally unsung heroes of any modern network.
So let's just start with a thought experiment. Imagine your network's central address book. The one thing that gives every single device its identity and tells it how to talk to everyone else. Imagine it just, poof, vanishes. What do you think happens next? You got it. One word, chaos. We are talking absolute network-stopping chaos where nothing new can connect and everything just stops working.
To really understand why this is such a catastrophe, we need to look at the single point of failure that's sitting right at the heart of the problem. So let's explore what actually happens when DHCP goes dark.
So what even is DHCP? Well, think of it as your network's super efficient concierge. Every time a new phone, a new laptop, anything tries to connect, the DHCP server greets it and hands it a unique IP address. It's kind of like getting a room key and a map of the hotel. Without it, you're just stuck in the lobby, going absolutely nowhere. And if that concierge suddenly disappears, well, the lobby gets very crowded very fast. No new devices can get their keys, so they can't get online. Your entire network just freezes solid. This is the very definition of a single point of failure, and believe me, it can bring a whole organization to its knees.
Now, of course, network admins have known this was a massive weak spot for years, and they came up with a few clever, but let's say ultimately flawed, ways to try and fix it. Let's take a look at these early attempts.
Okay, so there were two main approaches back in the day. Over on the left, you had failover clustering. Seemed like a good idea, right? You have a backup server, but here's the fatal flaw. Both servers relied on a single shared storage system. So if that storage went down, yep, everything went down with it. You just traded one single point of failure for another. Then on the right, you've got split scope. Here, you'd have two servers that would divide up all the available IP addresses. The problem? No IP address continuity. If your main server failed, your device would get a brand new IP from the backup server, which would immediately break any active connection you had. So not really a solution, was it? So yeah, we obviously needed something better. And with Windows Server 2012, we finally got it. This is where the modern solution, DHCP Failover, really enters the story. You see, DHCP Failover is a fundamentally different way of thinking. This isn't about some backup server just waiting in the wings. This is about two true partners that are actively sharing everything, all the address scopes, all the lease information, the whole shebang. They are constantly in sync, ready for one to take over for the other instantly without missing a single beat. So what makes this so much better? Well, for starters, it's ridiculously simple to set up. It's also flexible. It gives you two distinct modes, which we'll get into in a second, but this next one is crucial. It's seamless. Clients keep their exact same IP address, which, as you'll remember, was the massive deal breaker for the old split scope method. It even works across different physical locations. It's basically a solution that addresses every single flaw of the older systems.
So how does this magic actually work in practice? Well, it all comes down to two really powerful modes of operation.
You've basically got two flavors to choose from. First, on the left, is hot standby mode. In this setup, one server is active, handling everything, and the other is passive, just waiting. The analogy here is perfect. Think of a ticket counter where one agent is working and a second agent is standing right there, ready to jump in the instant they're needed. Or on the right, you've got load balancing mode. In this one, both servers are active, sharing all the requests that come in. This is like having two ticket agents working side by side, just getting through the line faster. This setup not only gives you that safety net, but it can also improve your network's overall performance.
So let's follow the journey from your computer's point of view. Okay, step 1. Your device sends out a request for an IP address. Step 2. The primary server just goes offline. But here's where it gets cool. Instantly at step 3, the failover partner detects that outage. At step 4, it just seamlessly responds to your request. And the real magic happens at step 5, continuity. You get your lease and you keep the exact same IP address. For you, the user, there was zero disruption, nothing.
And that right there is the whole punchline. The true magic of DHCP Failover isn't just that it works, it's that the resilience is completely invisible. For the person actually using the network, nothing ever went wrong. Their connection is stable, their work continues, the problem was solved before they ever even knew it existed.
Which brings us to our final question, and it's really for you. Look, this isn't some new experimental tech. It's been a core part of network infrastructure for over a decade. So looking at your own world, your own company, is that safety net in place? Is your network truly prepared for that single point of failure? It's definitely something to think about. Thanks for joining us for this explainer.